Hey College Algebra. In today's video, we're going to be analyzing rational functions by creating their graphs. So, in today's lesson, you guys will learn how to create a rational function graph by finding what their domain is, their asymptotes, and specific points, so you guys can graph something like this bad boy. Okay, so what are our steps to finding the graph of a rational function? So, first thing we do is take notes of this page. Take notes of this so that way when we're doing problems where we have to analyze a rational function, you guys will have this copied down. So first thing we do, factor the bottom and find the domain. And then after that, we can cancel terms and write in lowest terms. And what I mean by that is factor the top or the numerator and then simplify. And so cancel out all your like terms. Find your x and y intercepts. And you can do this in the simplified form, and I'll go over that here in a second, what I mean by that. Locate vertical asymptotes, and then locate all the other asymptotes, whether or not it has a horizontal or oblique asymptote. Then we'll make a table of test points to help us finish our graph. Okay, so let's do an example. So here, our first question is, analyze the graph of 2x squared minus 4x minus 6 divided by x squared minus 9. So first thing we do is we factor the bottom and find the domain. And so here I factored the bottom, and so here our domain, x cannot equal 3 or negative 3. Now remember, our domain doesn't necessarily mean those are our asymptotes or our vertical asymptotes, but that's just where x can't legally be. There might be a hole at one of these guys. And so what I've done here is now done the next step and canceled out like terms. And so what we get from here is that our vertical asymptote here is that x can equal negative 3. And so we can graph a vertical asymptote here. And now, since there's not a vertical asymptote at 3, that must mean that there's a hole somewhere here at 3. Anyways, we'll talk about that here in a second. Next thing we should do is find our x and y intercepts. And so before, when I was saying we can do that in simplified form, we can actually find our x and y intercepts here for this guy. So for our y intercepts, we set x equal to 0, and so we'll have 2 times 0 plus 1 all over 0 plus 3. And so our y-intercept is equal to 2 over 3. Okay, so we can go ahead and graph that right here. Now we just have to find our x-intercept, and that's where we set y equal to 0. But the nice thing about the x-intercepts is that we just have to find where our numerator is going to equal to 0. And that's because the numerator will equal 0, and therefore our y will equal 0. So what we want to do is find what values of x in our numerator will make our numerator 0. And so here, if x is equal to negative 1, and we're looking at our numerator, 2 times negative 1 plus 1 equals 0. And so negative 1 ends up being our x-intercept. Okay, so now let's keep checking along here. So here's the simplified form. We already found our vertical asymptotes. Now we need to find our horizontal asymptotes. And so when we're looking at our horizontal asymptotes, it's always easier to look at our original function. And here you can see that the powers are equal, so that makes our rational function equal. Therefore, we have a horizontal asymptote for 2 leading coefficients. We just say this is 1. And so a horizontal asymptote is equal to y is equal to 2. So we can graph that line here. I want to go ahead and pause the video and transfer everything from that last slide over to this slide. Okay, so I transferred those points over, and now that we've found our horizontal asymptotes, what is left? Okay, now all we have to do is make this table for the points. Now, for this right section, it's pretty easy to see what this asymptote is going to look like, or what this graph over here is going to look like. However, over here, we don't know if we're going to get someone that looks like this, or we're going to get someone that looks like this. So now we're going to have to create that table in order to figure out which one is right. Okay, so right here, I've created a table, and I've found values to the left of a vertical asymptote because we're not too sure what's going on there. And so first value I chose was -4, and you can see that its y value is 6 when we plug -4 in for our x's here. We don't need to plug it into here. It's just a waste of time. Okay, and now for -10, did the same thing, plugged it in, and I got it to be just around 2.5. And now we can start to see what it's going to look like over here. Okay, and there's our graph for the first example. All right, so now let's go ahead and look at our second one. Analyze the graph of this function. So the first thing we do is factor the denominator, and we show that x cannot equal -2 or 2. And now since we can't really simplify this at all, we can say that our vertical asymptotes are equal to -2 and 2. So let's go ahead and graph those. Okay, now what are our x and y intercepts? So our y-intercepts, we set x equal to 0. And so when we get that, we'll get at 3, our y-intercepts equal to 3 divided by 2 times -2, which is equal to -3/4. So our y-intercept here is just going to be -3/4. Okay, our x-intercepts, this one's a little different because there isn't an x value up here. Remember, with x-intercepts, we just want to find when the numerator is equal to 0. And well, for no matter what x we plug into here, since there isn't an x value here, there isn't going to be x-intercepts. So for x is not applicable. Okay, so we found our y-intercepts, found some vertical asymptotes, but we can actually make some pretty good assumptions. Since there isn't any x-intercepts here, you can figure that this bottom part is going to look something like this, right? So you know you won't have anything that looks like this, which should go through here, or anything that looks like this, because here you have x-intercepts. So you know those won't work out. But anyways, let's go ahead and find our other asymptotes. I'm going to go ahead and pause the video and transfer that information over. Okay, now we have our y-intercept vertical asymptotes. We got to find our horizontal asymptotes. Okay, now if we look here, we can see that it is bottom heavy. And since it's bottom heavy, that means our horizontal asymptote is y is equal to 0 because it is bottom heavy. So now we just got to figure out what's going on up here, what's going on up here. So from here, I'm going to assume that this is going on. Okay, and by the way, it could be down here or down here. So let's go ahead and create a table. I want to pause the video and show you guys the table I created. You guys should do this on your own as well for practice. Okay, so I created our table, and so here, first value is going to be 3/5 for x equal to -3. And so since it's above the horizontal asymptote, we assume it looks like this. And then for 3 here, you know, it's going to be some symmetry, but it's still safe to plug it in because these aren't always symmetric. Let's just go ahead and finish our graph. Okay, so one last example. And, okay, so for number 3, let's go ahead and analyze this graph. So here, The denominator is already factored, and so we can say here that x cannot equal 1. And so here, since we don't get any cancellation after we factored our numerator, that our vertical asymptote here, which is going to be where x is equal to 1. So we can go and graph that in. All right, so now let's find our y-intercepts. And so our y-intercepts is when x is equal to 0. So when we get that, we'll have 1 times 2 divided by -1. And so our y-intercept is -2. So we can graph that right here. All right, now let's go ahead and graph our x-intercepts. Now remember, our x-intercepts are where our numerator is equal to 0. And so x for our x-intercepts here are -1 and -2. So remember, we want this to be 0 and that to be 0. So we get -1, -2. Interesting. Makes you wonder what this graph is going to look like now. So you might have to try out some points here, see what's going to happen. But anyways, let's go ahead and find our horizontal asymptote. So I'm going to go ahead, pause the video, transfer the information over. So a horizontal asymptote, well, we can see that it's top heavy, and so we're going to have an oblique or a slant asymptote. Okay, so we'll go ahead and pause the video one more time and create a new slide with this on division. Okay, so remember, when finding the slant asymptotes, we need to use polynomial long division. Here we could actually use synthetic division, but I'm just going to stick to long division to stay consistent. So we need an x up here, so -x squared plus x. So here we need plus 4, -4x. Minus 4, we get our remainder here is -2. Okay, so we can rewrite our slant asymptote as r is equal to x plus 4 plus our remainder divided by our divisor. Now remember, as we go infinitely close to 0, this is just going to be 0. And so our slant asymptote is just x plus 4. Now, if we go back and graph this, you go ahead and just put it in here. Okay. All right, now we should start to see what our graph is going to look like here. Why is it that we're having those two x-intercepts? Anyways, I'm going to go ahead and pause the video and create a table of some x and y points to figure out what exactly is going on in our graph. What does it look like? Okay, so you guys should do this yourselves, and I'll unpause the video with some points. Okay, so I created our table here. Remember, we want to pick good points here, so I picked -5 because we're not too sure how it's going to act with this slant. I also picked between our x-intercepts to see if it's going to go above it, and it does, so we can plug a point right there. And then I also plug to the right of our vertical asymptote. And so for our value 2, we get 12. And then for 5, we get 8.75, which is still above the slant asymptote. So we can go ahead and graph this. It's going to be real close, but never crosses. And then also, you go ahead and graph this guy right here. Okay, so those are two examples of some graphs of rational functions. And so what you guys have learned is how to graph rational function by finding its domain, asymptotes, and then finding specific points to make the graph look accurate. Okay, thank you for watching. There's nightly questions posted below, and I'll see you guys next class.